All right, class, this video is about serial communication, and it's about the functions that are associated with the serial functionality of your Arduino. All right, so I'm going to write a sketch. We're going to talk about some of the components, and there's no circuit to build here because we're simply going to send messages to the Arduino from the computer via a serial connection, and the Arduino is going to relay something back. All right, so let's do it. All right, so I have a new sketch started here. I got a setup function and a loop function. In the setup function, I have typed serial begin 9600 to establish a serial link between my computer and my Arduino at 9600 bits per second. Now down here in the loop, I've typed out a function that we haven't seen before, serial.available. And so this is a useful function. What this does is whenever my computer, in this case, because that's what the link is between my computer and the Arduino, but if you can have a link between two Arduinos or an Arduino and some other piece of hardware that can communicate via serial communication. So whenever you have this link, in this case, when my computer sends a byte of information to the Arduino, that information, that data is going to be read into a memory location called the serial buffer. And what this function does, serial available, is it checks to see if there's any information waiting in that buffer. So this is going to return the number of bytes that are waiting, of information that are waiting in that buffer. So if I just do something like this, if I do, let's do a delay of 1 second, and then I'll do, I'm just going to print the result of this, calling this function serial.available to the serial monitor, and then let's see what it does. All right, so I have that sketch uploaded to my Arduino, and the serial monitor is opening and it's returning zeros. Once every second, it's printing out the result of calling this function serial.available. I haven't sent any information to the Arduino, so there's nothing in the serial buffer waiting. So serial.available returns 0 bytes. But if I type something up here in the, let's send the number 3, the type of 3 in the console up here and click send, now there's 2 bytes in the serial buffer waiting to be read. Let's type, a word, dog, send that. Now there's 6 bytes waiting in the serial buffer to be read, okay? So serial available returns, let me close this. Serial available returns how many bytes are in the serial buffer waiting to be read into the Arduino, okay? So one thing we can do with serial available is we can use it in an if statement. We can say something like if serial.available greater than 0. So what we're saying is that if there's any bytes waiting in the serial buffer, then let's save that. Let's read the bytes in. So we'll create a variable called myByte. And we'll use another function called serial read. So what this does is it reads the bytes that are stored in the serial buffer in a first in, first out kind of order. Okay, so if I read in that byte, and then let's print that. We'll print that byte to the serial monitor, and then we'll have a short delay of, half a second, okay? So let's save this and upload it, and we'll take a look and see. Okay, so the program's uploaded and running, but there's nothing being printed to the serial monitor. If I type a character here, 5, and send that to my Arduino, then serial available will be greater than 0 because there'll be something waiting in the serial buffer, so this if statement will be executed. It'll be read into memory, and it prints back to the serial monitor. So this is kind of weird though. I sent a number 5 and it returned the number 53 and 10. What's going on here? All right, so one thing it's doing here is down here I can specify when I send a character to my Arduino, I can append a new line character to the end of it, but I don't want to do that. I don't want any line ending. So let me close this and reopen it. Okay, so now if I send the number 5 to my Arduino, that 5 is stored in the serial buffer, and then it's read in using serial.read, and then it's returned, it's printed to the serial monitor. So this is like echoing. I send the 5 and it echoes that 5 back, but it gives me a 5-3. What's going on here? Well, what it's actually doing is when I send the number 5, it's actually sending, these are represented as ASCII characters. So if we look at an ASCII table, here's an ASCII table, and we find the character 5 down here. Probably can't see that too well, but the character, here, I'll zoom in. Right here, the character 5 is represented by the decimal number 53. So the actual data that's being received by the Arduino is the number 53. And when I ask it to, and that's being stored as a byte. So when I ask the Arduino to then print my byte to the serial monitor, it prints 53. All right, let me show you something else you can do. So I'm going to print my byte to the serial monitor, and I'm going to use a different function called serial write. And so what serial write does is it actually writes the ASCII character that corresponds to the decimal 53 to the serial monitor, and that should be 5. It should give us a 5. And then I'm printing a new line character to give me a carriage return. So let me save this and upload it. All right, now I'll type the number 5 and send it. And so I get, when I do serial print line, I get the number 53. Again, that's the decimal encoding of the character 5 in the ASCII character map. And then I get the number 5. When I use serial write, I get the number 5. It returns the ASCII character equivalent of the number 53. Okay, so I have a couple new functions here. I got serial.available, which checks to see if there's any bytes waiting in the serial buffer to be read in to my program. Serial read reads bytes in from the buffer into memory in a first in, first out kind of way. Serial print prints the value of that number, that byte, in decimal. And serial write prints the ASCII equivalent of that decimal number to the serial monitor. Let me show you one more thing. So what happens if you type in multiple characters? So let's type in the word hello and send. So this is going to send 1, 2, 3, 4, 5 bytes to the Arduino. There'll be 5 bytes in the serial buffer. They'll get read in one at a time and printed out to the serial monitor one at a time with a half-second delay. There we go. So the first character that gets sent is H, that's decimal 72. The second character is capital E, that's ASCII code 69 in decimal. And then 2 L's, which are 76 in decimal according to the ASCII code. And then in capital O, which is 79 in the ASCII code. So they get read in one at a time using the serial read function and printed to the serial monitor. So this is this program is just echoing. I'm sending data from my computer to the Arduino, and it's getting echoed back to the serial monitor. All right, so that's it for today. Just a quick overview of some new functions associated with the serial library. We in class last time we talked about how you can use if you have the need for more than one serial connection between your Arduino Uno and another device. Since the Arduino Uno only has one built-in hardware serial component, it's one UART, it can only create one hardware link with another piece of hardware using this UART. But if you need to have additional serial connections, you can simulate the functionality of this piece of hardware built into the microcontroller, this UART, using a library called software serial. And then all you got to do is specify the TX, the transmit pin, and the RX, the receive pin, and you're good to go. And you can use these same functions with the software serial library as you do with the built-in serial library. Okay, so until next time, that's it for today.